Hello guys, welcome to series 7 of mensuration and how we are identifying the different formulas for 2D shapes. So here we are faced with sector, segment, length of an arc. Okay, now from this first circle you have here, this is the radius. Now this part you see here is what we refer to as the minor sector, and then this point here is the major sector. While for the second circle, this point here is the minor segment, and then this point here is the major segment. So please identify and know the difference between sector and segment. If you check this very well, you will notice that here it's been there is this line here, right, which we call the chord. Okay, so whenever you have a chord in a circle, that circle is being divided into segments. But when there is no chord, then the circle, and then you just have to you have this radius and this radius, and then you have this arc without chord, then the circle has sectors. Is that okay? So please take note of that. Now, the first thing we will need to look at for is the area of a sector, meaning we're going to be looking at this part here. Okay, area of a sector is given as theta over 360 degrees, right, times pi r squared. Now, whenever we are talking about circle, always remember pi is part of it, right? Whenever we are talking about the formula of a circle, pi is part of it and is always constant. It's either you are given as a fraction or as a decimal. As a fraction is 22/7. As a decimal is 3.14. And then your radius will be given from the question, right? Equals 1/2 times L R. Now, you will be wondering, what is L? Here, L stands for the length of an arc, or the length of the arc you'll be given. From this point to this point is the arc of this sector, right? So uh, the area of a sector, theta over 360 times pi r squared, which is equal to or same as 1/2 times your length times your radius. Okay. So how do you now calculate for length of an arc? Very, very important. Assuming you are not given the length of the arc, how do you now calculate for the length of an arc, which is this L here? So of an arc is given as theta over 360 times 2 pi r. So even if you are not given length of an arc and they ask you to calculate for area, you will be given this angle here, that you'll be given pi, you'll be given radius. Once you have this, you are okay. You can calculate for area, you can calculate for length of an arc. So whatever angle you are given here, divided by 360, multiplied by 2, multiplied by pi, and multiplied by your radius, you get length of an arc. Then once you've gotten that length of an arc, you can now substitute it in here to get your what? Area of a sector. Is that okay? Now let us move to area of a segment. Area of a segment is theta all over 360. Please note the difference between sector and segment. We have the pi r squared minus, please note we have minus 1/2 r squared sine theta. So this is the formula for area of a segment. Is that okay? Theta over 360 times pi r squared minus 1/2 r squared sine theta. So you'll be given this, okay? You'll be given pi either as a fraction, and then you'll be given radius. This is 1, this is 2. Now, once you have this, to get the area of a segment is done already. What about the perimeter of a sector? It's given as theta all over 360 times 2 pi r plus 2r. So these are what you'll be coming across as we progress into taking examples and solutions for 2D shapes. After which, we'll go into 3D shapes where we'll have to start calculating for surface area of a cylinder. We'll have that of a cone. We'll start treating that of a sphere. We'll do all those 3D shapes. But presently, we're going to be focusing on 2D shapes, so you master it very well, okay? Please practice all the formulas from series 1 to series 7, after which we are going to be taking examples on each of these series that we've done. Okay, just one example each if possible, or two per each series if possible, but we'll be taking it gradually so that as you learn, you follow along. So, see you in our next series, which begins our example. Bye bye.